Hi all, welcome to Geeks for Geeks. I'm Utkarsh Kasarwani, your DSM mentor, and going to solve today's problem of the day. So the name of the problem is symmetric tree. So the question is saying that given the root of a binary tree, check whether it is symmetric, that is whether the tree is a mirror image of itself. A binary tree is symmetric if the left subtree is a mirror reflection of the right subtree. It is saying that let me copy the nodes. So 1, 2, 2, then we have a 3, 4, and then here we have 4, 3. So it is saying that if we will make a mirror here or place a mirror here, so this tree should be a symmetry to this. Okay, so you know that in the real life too, when you will see in the mirror, so left will be seen as right in the mirror, correct? So here both was 2, so it is 2, but here you can see the 4, so 4 is more closer to the mirror. So in the right subtree 2, 4 is closer to the mirror. So what it does indicate, if we will see, it indicates that the left value of any node will be the right value of this side node will be the left value of this side node, and the left value of this node is the right value of this node, correct? So we will apply this logic at each node. First of all, we will say that whether the values are equal or not. If the values are equal, so we will go to the right side of one's node and left side of another's node. Okay, and similarly, if we will go to the left side of the another node and right side of this side node, and I have to keep checking that whether my this value is equal or not. And at any point of time, let's suppose the values are not equal, so we will return a false. And if at in any of the subtree ends but other subtree is still there, so in that case we also have to return a false, else in other condition we have to return a true. So let's try run one of the example. So 1, 2, 2, then we have a 3, 4, 4, 3. So what I will do, I will call a function, this is root, so I will call a function solve root of left means 1 of left. So 1 of left is 2, 1 of right is also 2. So I will call this function from our main function. Okay, and what I will do here in this 2, 2, first of all I will check whether the values are equal. Yes, both values are equal. Okay, then I will again call this left of 2 and this right of 2. So if I will go to the left of this 2, so it's 3, right of this 2, it's also 3. Similarly here I will go to the right of this 2, so it will be 4, and left of this 2, it is also 4, correct? So the values are still equal. We will further go down. So we are at this place. Now we will again go. So left of this is null, comma, right of this is also null. Here also right of this this 3 is null, and similarly right of this left of this 3 is also null. So if both the values are null, so we will have to return a true here. So we'll get a true here. Similarly for this 4, we will check, so we will get null, 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 null. So the values are null, so we have to return true, true, true. Here both are true, so true. Here also true, and then again upside to true, correct? Is this fine? Okay, now what I will do, let's suppose here there was one more value, let's suppose 5. So when you was here, when you go to the here, this left of 4 was null. Okay, when you go to here, the right of this 4, so you will have a 5 here. So when both values are not equal, then in that case you have to return a false. Or if the case was like this was 5, this was 4, so here you will have 5, 4, so still you have to return a false. So let's code this solution. So I will create a bool function, bool sol, and we have a root, so node star root 1 comma node star root 2. What I will do, I will first check that whether my both values are equal to null. So if root 1 is equal to null and root 2 is equal to null, then in that case we have to return a false. Else, if let's suppose my root 1 is equal to null, but my root 2 uh, equal to null, means if both were null, then we have to return a true, not false. But if any one of them is only null, other exist, so in that case it is a false condition. Then again I will check that if my root 1 of data is not equal to root 2 of data, means the values are not equal, so in that case also we have to return a false. Else we will check for the left and right. So how we will check? We'll call root of sol root of 1 of left. So for this I will call the root 2 of right. So I will call root 2 of right, and I have to take a AND because both values should be true for making the whole tree as a symmetric tree. Solve of root 1 of right comma root 2 of left. Okay, and here we will return solve of root of left comma root of right. Let's compile and run this. Submit this solution. Okay, so if I will talk about the time complexity, so I'm reaching each and every node only once, so my time complexity is O of n. N is number of nodes. If I will talk about the space complexity, so only recursion space is there, which will be O of height, the maximum depth of the tree. Okay, so thanks for watching the video. If you have any doubt, you can comment it below. Have a good day. Bye.